These are complementary, they add up to 90. If we have two angles, let's say this one here, and this one here, and what's important is that I have a straight angle here. So the angle through this vertex right there is 180 degrees. And let's call this angle, here's alpha and beta again. So alpha would be this angle here, beta would be that angle there. And so my angle alpha in this case plus my angle beta, they add up to 180 degrees instead of 90. That's called supplementary angles. And it does not have two P's. Supplementary angles add up to 180 degrees. So any pair of angles you have that make a straight angle, when you put them together, they give you supplementary angles, which are a little bit different than, say, complementary angles, which add up to 90 degrees. So I just want to play with another scenario. Another thing about the 90-degree angle, if two lines meet at a 90-degree angle, so this, let's say this is line L there, and that's line M, and they meet at 90 degrees, then they're perpendicular. So L is perpendicular to M, since they meet at a 90-degree angle. 9 at a 90-degree angle. All right, so let's go play in Geogebra a little more with some angles. And I'm going to get rid of this. And again, if you find you make something you don't want to get rid of it, then you can just save it. So if you think you might need it later, just hit save. Again, you have to be signed in, you have to have an account, and you can sign up for an account by giving them a username and password, or use a Google or Facebook account to sign in, which is what I do. So maybe I want this, and I will call these what, complementary. Complementary. Go. Complementary. And I had it set on share when I hit save, which means I could get the shareable link and then let somebody else play with it if they wanted to. And when they get it, they basically get a new copy of it. All right, so that's saved. Let's clear it, or clear it and don't save it. We're going to make a line, 2 points on it. And then we're going to make a line parallel to that. And so in the construct tools here, I have choices like perpendicular line, perpendicular bisector, parallel line, angle bisector, tangent lines. I don't think we'll get the tangent lines this turn, but we're going to put parallel lines next. So if I click on parallel line, it says, okay, select a point and a parallel line. So I don't have a point yet, but it's waiting for one anyway. So I should just be able to click out here and it will make a point for me. And then I can just click on this line down here. So it just made a line through C parallel to line AB. Next thing I'm going to do is I'm going to make another line through AC. So I'm just going to go back to the line tool and put that line through there. So anytime we have a line that crosses parallel lines, that line that crosses the parallel lines is called a transversal. I'm just going to play around with transversals here for a moment. And we're going to run out of time. let's call this line L and this line M. So L is parallel to M. Sometimes a shorthand for that, you'll see L and then two vertical lines next to each other and then M. And so that just means L is parallel to M. And then I have this other line here, let's call that line N. N is a transversal to L and M, because L and M are parallel. So any line that crosses parallel lines is called a transversal. So let's play with our transversal here and some angles. Angle tool, find it. Let's see, measure angle. And I've been selecting 3 points, but it also says you could select 2 lines. So I could select what I was calling line M here, and then select line N here, and it will find me that angle there. And on yours, you should have a slightly different angle. Often that number appears in not the best location, so you can always move it to see it better. So I got an angle of 74.2. That's the angle I found there. So what I'd like you to do is go around on your transversal line. There are 1, 2, 3, 4, 5, 6, 7, 8 angles that are formed as line N crosses lines M and L. So what I'd like you to do is I'd like you to measure all 8 of these angles. And yours will be different than mine, and that's okay. But just measure each of these 8 using that angle measure tool. 2 reasons to do this. 1, just to play with the software, see what it can do. But 2, there's some interesting patterns here. I'll give you a moment to do that. So with a few more points, I can more specifically measure each angle. So let's see, A, C, E, there we go, that's one of them. F, C, G, there's another one. Turns out just using 2 lines to measure angles isn't always enough. We need some points to be more specific about which angle in the region we want. And then we got to deal with all this overlap. Oh, well, this is interesting. Oh, I know what went wrong. My point G isn't actually on the line. Fix that. But if I click on point D, it won't move off the line, it will only move on the line. So that is one thing about GeoGebra. Where you click depends on what you can do with the point. So G, I actually missed the line. Notice I can put it anywhere. But point D, I got it on the line and I can't move it off. So I'm gonna have to delete, oops. Try that again. On the line, please. And the reason I knew something was wrong is those angles weren't lining up to what I thought they should. Anybody have an observation about the angles that you found based on your transversal of the parallel lines? There are a lot of different angles here. Anyone having trouble building this? Now's the time to ask.